The science of the universe, also known as cosmology, is the study of the origins, structure, and evolution of the universe. One of the most important discoveries in cosmology is that the universe is constantly expanding. This was first proposed by Edwin Hubble in 1929 and has been confirmed by numerous subsequent observations. The expansion of the universe is thought to be driven by dark energy, a mysterious force that acts in opposition to the gravitational pull of matter. This dark energy is thought to make up about 68% of the universe's energy density, with the remaining 32% being made up of matter and radiation. One of the key pieces of evidence for the expansion of the universe is the observation of redshift in the light from distant galaxies. Redshift occurs when light from an object moving away from an observer is stretched to longer wavelengths, making it appear redder. This effect is similar to the sound of a siren on a moving ambulance, which sounds lower-pitched as it moves away from you. By measuring the redshift of light from distant galaxies, scientists can determine how fast they are moving away from us, and therefore, how fast the universe is expanding. Another piece of evidence comes from the cosmic microwave background radiation. This is a faint glow of light that fills the universe, and is thought to be the afterglow of the Big Bang. By studying the patterns in this radiation, scientists can infer the structure and history of the universe and confirm that it is indeed expanding. An interesting way to think about the expanding universe is that it's like a balloon that is being inflated. Just like the balloon, the universe is getting bigger and bigger, but the distance between any 2 points on the balloon's surface doesn't change. This means that galaxies that are farther apart from each other are moving away from each other faster than those that are close together. The belief that the universe will expand forever is based on the current understanding of the universe's overall energy balance and the properties of dark energy, a mysterious form of energy that makes up about 68% of the universe's energy density. One of the key factors that determines whether the universe will expand forever or eventually collapse in on itself is the overall energy density of the universe, which is determined by the balance between the energy of matter and radiation and the energy of the dark energy. If the energy density is greater than a certain critical value, the universe will eventually collapse in on itself in a big crunch. If the energy density is less than this critical value, the universe will continue to expand forever. Current observations suggest that the universe's energy density is very close to this critical value. However, the majority of this energy density is in the form of dark energy, which has a negative pressure and acts to accelerate the expansion of the universe. This means that the expansion of the universe is not slowing down due to the gravitational pull of matter, as one would expect, but is instead accelerating. The most accepted theory for explaining this accelerating expansion is the cosmological constant, which was first proposed by Einstein in 1917. It states that the energy density of the vacuum of the universe is not zero, but a positive value, and this value is the same as the dark energy. It's like a repulsion force that drives the galaxies apart from each other. The evidence for the accelerating expansion of the universe comes from a variety of observational data, including the observation of supernovae in distant galaxies, measurements of the cosmic microwave background radiation, and the large-scale structure of the universe. All of these studies have consistently shown that the universe is not only expanding, but also accelerating in its expansion. In summary, the belief that the universe will expand forever is based on the current understanding of the properties of dark energy and the energy density of the universe. The observed accelerating expansion of the universe, driven by dark energy, suggests that the universe will continue to expand forever without collapsing in on itself. The ultimate fate of the universe is a topic of ongoing debate among cosmologists, with two main possibilities: that the universe will eventually collapse in on itself, or that it will continue to expand indefinitely. One possibility is that the universe will ultimately collapse in on itself in an event known as the Big Crunch. This scenario is based on the idea that the overall energy density of the universe is greater than a critical value, known as the closed universe solution. If this were the case, the gravitational pull of all the matter in the universe would eventually overcome the expansion, causing the universe to stop expanding and start contracting. As the universe contracted, the matter in it would become denser and hotter, eventually leading to a singularity where all the matter in the universe would be concentrated into an extremely small and dense point. The other possibility is that the universe will continue to expand indefinitely in an event known as the Big Freeze or Big Rip. This scenario is based on the idea that the overall energy density of the universe is less than a critical value, known as the open universe solution. In this case, the expansion of the universe would continue to accelerate, driven by dark energy, until all matter in the universe is so far apart that it can no longer interact through physical processes. As the galaxies and stars move farther apart, they will eventually be unable to form new stars, and existing stars will exhaust their fuel and die. Eventually, the universe will be dark and cold, with no energy or matter to sustain any kind of life. Current observations suggest that the universe's energy density is very close to the critical value, which means that the fate of the universe is currently uncertain. Some scientists believe that the dark energy density will decrease over time and the universe will start to contract. But others think that the dark energy density will stay constant or even increase over time, leading to a Big Rip scenario. We hope you found this video informative and thought-provoking. Remember to subscribe to our channel for more videos on the latest developments in cosmology and other science-related topics. Thank you for watching.